I'm now going to take a clean-up cut on the face of the boss. The drawing also shows cleaning up the OD of the boss, but no dimension, and that's because that's not critical, so we'll just do minimum and make both crank discs the same. Okay. Good. Well, that's cleaned up very nicely. That looks great. The ragged edge on here I can take care of with a nice chamfer. But now it's time to take some measurements. So this is actually all going very well. I used a depth micrometer to carefully measure the height of this face to this face, and then a 1-inch regular micrometer to measure the thickness of the web. And what I've found is that I am 1/10 over on total length, and that I am under height on the boss, and that I'm too thick here, which is exactly where I want to be, because now I can take a little more off of this face, which will increase the height of the boss from that face to that face, and decrease this. And I've got that balanced out quite nicely. If I take off 40 thou off of this surface, I will be on dimension here, and I will have 10 thou to remove here. I think that's right. I have to go check my numbers again. It's a balancing act with these castings. You have to try and take material off all the faces in such a way that everything comes in. It's not like just machining a piece of bar stock where you start one end and you can put all your steps in. You have to be cognizant of all of these different features, and that's part of the fun, honestly, with using castings, is figuring out, well, how you're going to hold it and how you're going to get all the surfaces machined to end up at final dimension. So I'm just going to go review my measurements and calculations one more time, and then we'll come and make some finish passes. Let's see. Revising my plan slightly, I'm going to take 30 off of this face. That will leave me 10 on the back side. The front is now finished. That's as far back as we're taking that. And I'm not going to change the diameter. I think we're going to call that good. So 30 to come off here. Then I'm going to skim 5 off what I can get to on the back to make my reference surface. Then turn it over and take off a total of 10 from the back. But the 5 gives me a cleaned up surface to clock. So here we go. 10 thou at a time, nice and easy. Right, so I got this finished up. I put a little bit of a chamfer on there and I broke the edge here. And now I've got a new tool set up, and I was just setting this up on height using my height gauge. As you can see, what I'm going to do is go to the back side, so without disturbing the setup at all, I'm going to take a cut. I'm going to set my X0 right now so I don't go in any more than that, and I'm going to take 10 or 15 thou on the outer perimeter off the back side. Now it turns out earlier on I'd measured this thickness wrong. Don't know why I did, but it was okay. It was wrong in my favor, and I caught that, and now I have the height of this boss perfect, and I have more stock on the back of this than I'd anticipated, which is great. So this face is finished, this diameter is finished, this face is finished, this diameter is finished, and now it's just the back side. So with that, let's do some cleanup. Now you can't see it, but I've got cleanup all the way around, which I expected because it wasn't out of flat by as much as 10 thousandths, which is what I took off. So it's now time to put my money where my mouth is and take this off and turn it around and clock this back face in. Alright, I'm going to do that off camera. Alright, as you can see, crank web is turned around, and I did shoot a bit of footage of truing up this face with the other camera. So when I merge that all together, you should, the wonder of video technology, you'll see that happening. It was a bit of faffery, honestly, to get that done. A bit more difficult than I thought, but right now just a couple of skim cuts to do this side. So I'm going to touch off on this surface, clean that up, measure it, and then finish it. Visually running very true. Two passes at 10 thou each, and done. .3784. Shooting for 380. We'll call that a win. So this is complete at this stage. It's now, I have to make the second one. I'm not going to film that. And then both go to the mill together. So I've got to do some off-camera work and then I will be back. Okay, I have both crank webs machined. Here's the other one. Now it's time to put the cross pin bore in, crank pin bore I should say. So the drawings have you taking this hole to 5/8 with a very close tolerance, and this bore to 3/8, again with a close tolerance, with the idea of pressing in the crankshaft and pressing in the crank pin. Now the drawings specify the crankshaft as a 5/8 shaft with a slight lead in to press in here. Currently this hole is ½ inch. It's actually 0.499 in diameter, and my original plan was to come to this stage, open this out to the 5/8 and put the 3/8 here in this operation, but I think what I'm going to do is leave this at ½ inch, and I'm going to make the shaft with a step, a ½ inch step on it, so that I have a shoulder to locate against this surface. Now the kit supplies a piece of 5/8 cold rolled round bar or rod, as it's correctly known. And the thing about cold rolled rod or round bar is that it is never on size in any particular close tolerance, and it's never round. So attempting to use a piece of just plain cold rolled in this application is really inappropriate. So I have ordered a piece of steel which is actually ground to size, so a very tightly controlled piece of material, and I'm going to use that instead. I could have got a piece of 3/4 inch and then turned it down, and that's fine, but it just makes sense to use a piece of accuracy stock. So that's what I'm going to do, and turn a shoulder on it to press into here. So I'm going to leave this as it is. One of the reasons I'm going to leave that as it is because in setting this up, I now know that this bore is perpendicular to this back side. This back side is obviously on my 1, 2, 3 blocks here, and to save you all the pain of watching me do all of this setup, what I've done is I've got a 499 gauge pin in here, which is a very close fit. I've used that to locate the center of this hole, and then I've used a 3/4 inch gauge pin just to center this feature at the back. Now if I use the hand feed, I can feel this 499 pin go in, and there's absolutely no friction. So I feel very confident that this hole is very perpendicular to the rear face, which is the important geometric relationship. So given that, I'm just going to leave that hole as it is, make use of it in that way. So my next the next step is to drill and ream the 3/8 inch hole here. So just to show you how I aligned that, let's take this out. Like I say, these are actually gauge pins. I'll bring this down close. Move the table over to the boss. And I can feel very similar feel either side of that pin, so visually that boss that we're going to drill through is centered in the Y direction with the bore, as well as it needs to be. And when I put my center drill point in there, I will quickly put the calipers on and just make sure that it's you know, centered on that feature, just to maintain the look of the thing. So let's bring this out and go and double check the center. Again, feeding this down through hand, not using the crank feed, because by hand, if there's any out of concentricity relationship, you'll feel it, and there's nothing. That slides right in and all the way through. And this is the largest pin that will fit in that hole. A 500 pin won't go in. So that's, I feel, as close as we need to be. And as you can see on the DRO, we're at X0, Y0, so that's perfect. So now what I will do is install the drill chuck, put a center drill in there, move the 1.25 inches over, lock down the tables, and then I will drill and ream the hole, and I'll go in 3 drill sizes before reaming, just to, I want to keep that hole straight, so I don't want to take out too much material each time. Now, I'm going to start locking down the table. As you can see, when I lock the table down, it can affect the actual position of the table by a few tenths, so that's okay. I kind of get it loaded and then finally move into position. And finish locking down tight. By my eye that looks okay, but then I'll just do a crude measurement here. .3365 versus 348. Yeah, that's close enough. And this time 3345, 3315. So plenty well aligned. We'll go with that. And there we are. Now what I'll do is unclamp this, deburr that, and we'll go over to the inspection department and see how well these holes line up. Here we are in the inspection department, otherwise known as the granite slab at the end of the bench. And here are the two crank webs. As you can see, very reasonable looking parts. I'm within a couple of thousandths on every dimension in terms of thickness, diameter, heights, all of that. That all went very well. So now what I want to do is check the relationship, the size and the relationship of these holes. It's critically important for this engine to run smoothly that the center position of this hole to this hole is the same on both crank webs, and I was seriously contemplating attempting to machine these two to clamp together. That was my original plan, but in order to best do that I would have had to have them joined together like this, and then I'd be setting up on this face, and I really didn't want to do that. I wanted to set up on this face because this is the one that has to be perpendicular to these bores, because the crank pin gets pressed in here and you want this to all run true. Now with the way I machined these faces should be very parallel to the back face, and I may actually check that just for fun, but it's not actually very important. This face doesn't really do very much. Anyway, enough waffle, let's check these holes. So have a 1/2 inch crank pin, gauge pin, crank pin, I haven't made the crank pin yet, and a 499 gauge pin. So the 1/2 inch will not go in either one. Oh. And the 499 does, and as you can hear, that's a good fit. Now for this hole we have 376 pin, almost goes in that one, tight, and a 375 pin. Which goes in both. That one might be 5/10 larger than that one, maybe. So that's great. Now what about the relationship of these two holes? Well, so if we take the 499, which is a tight fit in both parts, and the 375, which is a tight fit in both parts, or both close fits, if my machine has enough precision, then with these faces held tightly together, both pins should go in. If they don't, then there's a misalignment. So let's see, 499, .375. Oh, holding those tight together. Is that in focus? Sorry, I've had my hands in the way the whole time. I can't do any better than that. Those are dead on. They slide right through, nice and easy. So those crank webs are as precisely made as I can possibly make them, I think. I'm extremely happy with how these have turned out. Extremely happy. So there you have it. That's the crank webs. Those are now complete. Like I say, I'm using a slightly different approach to the design than PM Research have. Nothing wrong with their design. I just like the idea of a shaft firmly located on a shoulder, so I'm going to go that route. So these are done. Next part up will be the crank pin. So stick around for that excitement. Thanks very much for watching. Hope you got some kind of enjoyment out of this process. If you've got any suggestions as to ways I might have done it better, from a standpoint of precision, that's kind of my thing. I'm less concerned about numbers of setups and time it takes, because you know, this is a hobbyist thing. In a production world I might be more interested in saving time, but if you have any advice on how to achieve better precision, I'm always interested in that. Thanks very much for watching. Take care. Get out to your own shed whenever you can, and always be the sharpest tool in the shed. Bye for now.